Greetings, fellow grade 11s. It is still your favorite tutor, Mr. Shajwayo, and welcome to Back to Basics. What we are doing basically today, we are looking at our exponents and sets, right? So we are still looking at different past papers, right? Where we are trying to solve different questions which we may encounter in our different examinations, right? Once again, so this it is the paper from the Gauteng province, right? I think this was written in June 2024. Are we all fine, right? Now let's see in terms of what is it then that we were supposed to do in here. Now let's look at the first one, right? So in here, can you see that you are given that you are having this is same as 2 to the power of negative 1 plus this is same as 3 to the power of negative 1 squared, right? Now, what is the first thing here that we can do? Can you see that we can start by writing these negative exponents as positive exponents, right? So, and how do you do that, right? Remember when you're having a to the power of negative 1, this is same as 1 over a, right? So the same is true here. This is going to be 1 over 2 plus this is going to be 1 over 3 squared. Are we all fine, right? And now after that, what is it then that you're going to do now from here? To add these, right? Remember these are going to what? Remember they said without using a calculator. So these are fractions, right? So to try and add these, what is it then that you're going to do? Now we are going to look at our LCD to say what is going to be the LCD that that both of these number can also be factors of, right? So can you see that now from here we are having 2, we are having 4, we are having 6, right? This we are having 3, you are having 6, we are having 9, right? Which means now our LCM, right? Or which is the lowest common multiple in this case is going to be 6, right? So we want both of these to have the denominator of 6, right? So what is that you're going to do now? So for these to have the denominator of 6, the first one you're going to do what in here? You are going to multiply the numerator by what? The numerator by 3 and also denominator by 3. Here you are going to multiply the numerator by 2 and the denominator by 2, right? And how is this then going to assist us, right? So this is going to be same as 3 over 6. This is going to be plus, this is going to be same as 2 over, and this is going to be 2 over 6, right? Which is squared. Now that the denominators are the same, we can add them, right? So we can say, write everything under one denominator. This is same as 6 now. 5 plus 2. 5 plus, or rather 3 plus 2 gives me 5, right? Look at me, I'm already thinking about the answer, right? So this is squared. And now I can come back. What is 5 squared? It is going to be 25. And then what is 6 squared? This is going to be 36. How it's okay, right? So this is going to be how we go about to do this question, right? Now, let's continue and then let's look at the next question, right? Now, in the next question, what is it that you are given? So here you are given 2 multiplied by, this is 4, right? So what is 4? 4 is same as 2 squared, right? 4 is same as 2 squared. Now, this is going to be to the power of x plus what? This is to the power of x plus 2. This is going to subtract what is going to be 4 also here. Can you see that 4 is same as 2 squared, right? So this is same as 2 squared. This is same as x minus 3, right? Now, this is going to be divided by, right? What is going to be the denominator here? Can you see that here we are having 2 to the power of x multiplied by 2 to the power of x, right? And now I want to apply the law then after this, right? And now what is it then that I can do now from here, right? So this is same as what? This is same as if now, for an example, I look at this is same as 2, right? Now, if let's say I am multiplying here the exponents, right? Remember, when I multiply the same base, I am going to add the exponent, right? So, but I must start here. Remember, this is 2 to the power of 2x, right? And then this is going to be 2 multiplied by 2, which is 4, right? And then this is same as 1. And when I multiply powers of the same base, I am going to add the exponent, right? So now I am saying this is same as 2 multiplied by, this is going to be 2 to the power of 2x multiplied by, this is 2 to the power of what? This is 2 to the power of 4, right? Subtract, this is 2 to the power of 2x multiplied by, this is going to be 2 to the power of what? Negative 3. Or rather, this is negative 6, not negative 3, but negative 6, because the 2 is also multiplied outside. Are we fine, right? Then now I'm going to come back into my denominator, and then this is same as 2 to the power of 2x, right? Because when you multiply powers of the same base, you add the exponent. And then after, what is it that I'm going to do? Now I'm going to take out a common factor everywhere, right? Now, what is my common factor here? So this is same as 2 to the power of 2x, which is common in both sides, right? And now when I do that, can you see that here I am left with 2? This is same as 2 multiplied by 2 to the power of 4, right? Subtract, this is going to be 2 to the power of negative 6. Close bracket. Now this is going to be divided by what? This is divided by 2 to the power of what? 2 to the power of 2x, right? Now I want you to look at this. Can you see that since there's a multiplication sign, these are going to cancel each other, right? The 2's and 2's are going to cancel each other here. And now what is it then that you're going to end up having here? For an example, now what is that we are going to have end up having here? This is going to be same as what? Now this is going to be same as 2 multiplied by 2 to the power of 4. This is same as 2 to the power of 5, right? Right? This is going to be same as 2 to the power of 5. 2 to the power of 5. This is going to subtract. What is going to this one? This is going to be 1 over 2 to the power of 6 altogether. And then now, what is going to be our response thereafter, right? Now, what is this? What is 2 to the power of 5? I think 2 to the power of 5, it is 32, if I'm not mistaken, right? 2 to the power of 5, it's given by 32, right? So, which means this is same as 32. All right, subtract, this is going to be 1 over 2 to the power of 6. I think this is 64, if I'm not mistaken, right? I think this is 64, which is going to be your 64. And then now from here, what is it then that I'm going to have here? This is going to be same as what? Now from here, what is it that I want to do now from here? Remember they said without use of a calculator, right? So what I can do now from here, this is same as over 1, right? So what I can do now to get rid of this denominator, right? What I can do now from here to get this to have the same denominators, right? So what I can do here, I can multiply this side by what? By 64 in the numerator and also 64 in the denominator. So these can be one and the same thing, right? So which means now here I am going to say 32 multiplied by my 64, right? 32 multiplied by 64. I think this is 2040 if I'm not mistaken, right? Right? When I say 32 multiplied by 64, I think this is 2040, right? So this is going to be 2040. Are you all fine, right? So this is going to be same as 2040. Wait, yes, 2048. Why am I saying 4? This is 2048, right? 2048. Now this is over 64. Subtract 1 over 64. Now, because both of these are over 64, now this is going to be same as now 64, right? Let me write this here. This is same as 2048 subtract 1 over 64, which means this is same as 2047 over 64 altogether. Now, there's no way that I can be in a position to uh solve this altogether, right? So which means now this is going to be the answer and the response that I am going to get in this particular question, right? So I am hoping that this makes sense. Now let's move swiftly along to our next question and see what is it that we can do in that particular question, right? Now from here, now we are saying from here we are going to look at what we are going to look at our 3.1.2. Okay. Now, what is it that we can do from here? I know, we are going to look at this question and we are going to think this is one of the most difficult question, which is not necessarily the case, right? So I want us to look at this carefully, right? Now, I want you to do this, right? Can you see that now from here, what is it that I can do? This is given by 3 to the power of negative 1 over 2, right? Okay. So now what is this? This is same as 3 to the power of negative 1 over 2, right? 3 to the power of negative 1 over 2 into bracket. This is same as root of 12 plus this is going to be same as the root of this is cube root of 3 into root of 3, right? Now what I can do from here, right? Now, I want to start here. I want to get rid of the root first, right? So this is 3 to the power of negative 1 over 2 into, right? Now, what is going to be my root of 12, right? I think we know that root of 12, remember 12, it's same as 3 multiplied by 4, right? Right now, and we know that the square root of our 4 is going to be same as 2, which means now our 12 is same as 2 root 3, right? So this is same as 2 root 3. Are we fine? This is going to be now. I want to get rid of this firstly, right? Now, what I can do now from here, can you see that I want to get rid of the cube root 3 into whatever that I have in here, right? So I'm going to write everything what I have here as 1 over 3, right? So which means this is going to be plus, this is same as this is going to be same as 3 multiplied by root 3 to the power of 1 over 3, if I'm not mistaken, right? So I just got rid of the root in there, right? And now what is it then that I'm going to do now from here? Now I can still move back now from here and say, from here, what is it that I have? I want to get rid of whatever root that I have in this bracket of mine, right? So can you see that this is same as 3 to the power of negative 1 over 2? Into brackets now, this is going to be 2 multiplied by 3 to the power of 1 over 2, right? So I'm getting rid of this square root here, right? So this is going to be also multiplied by, now can you see the 1 over 3 is applicable here and is also applicable here? So this is going to be plus. This is same as 3 to the power of 1 over 3. Now, if I get rid of this square root here, right? Remember, this was going to be 3 to the power of 1 over 2, right? Now, this is going to be again multiplied by 1 over 3 now, which is the outside one, which is the 1 over 3 here. Are we together? And then now from here, what is it then that I can do from here? Let's see. So now from here, I am multiplying powers of the same base, so I can add the exponent. So this is same as 3 to the power of negative 1 over 2 into, this is same as 2 multiplied by 3 to the power of 1 over 2. This is going to be a plus. Now look at this. This is same as 1, right? This is same as 3 to the power of 1 over 3 plus, what is this, right? 1 multiplied by 1, it's 1. 2 multiplied by 3 is 6. So which means this is going to be 1 over 6. Altogether. So this is same as 3 to the power of negative 1 over 2 into, this is same as 2 multiplied by 3 to the power of 1 over 2. This is going to be plus, what is 1 over 3 plus 1 over 6? 1 over 3 plus 1 over 6, this gives me, I think this is going to give me 2, then 2 plus, then 2 plus 3, right? Now let me look at this, right? So I am saying this is 1 over 3. This is going to be plus, this is going to be 1 over 6. Are we together? Now, these 2 is going to give me 1 over 2. This is going to be half, right? So, which means this is also going to be same as 3 to the power of 1 over 2. Are we together, right? And what is it then that I can do now from here? I want you to look at this, right? Now, can you see that here inside the brackets, I have 2 factors, right? I have 2 factors which I can take out a common factor of, right? So now I can start with the outside one. So this is 3 to the power of negative 1 over 2. Now this is going to be multiplied by now. Can you see that 3 and 1 over 2 and 3 and 1 over 2 is common between the two, right? So this is going to be same as multiplied by 3 to the power of 1 over 2 because I'm taking it as a common factor. And then here I am left with 2 plus, now remember here I've taken out the 1 over 2, the 3 to the power of 1 over 2, which means I am left with 1 here, right? And then now what is it then that I'm going to have now from here, right? Now from here, can you see that this is 3 to the power of negative 1 over 2 multiplied by 3 to the power of negative 1 over 2, right? And these signs are opposite, right? So when you multiply powers of the same base, you add the exponent. This means this is going to be same as 3 to the power of 0 multiplied by what is 2 plus 3. This is going to be same as 3. Okay. And then what is going to be the answer here? 3 to the power of 0 is same as 1, which means my answer here is going to be same as my 3. Altogether, right? So I am hoping that all of this is making sense and we can be in a position to solve this question. Now let's move swiftly along to our next question and see, right, in terms of what is it that we can get in here so that we can solve at the end of the day, right? Now let's look at now our 2.2.1, right? Now in there we are having our exponential equations, right? Now, what is it then we can do? What is that we can do with our exponential equations? For an example, right? This is same as what? Can you see that this is going to be same as what? We are given that you're having 2 to the power of x. This is 3 over 4 is equals to what? This is equals to 16. Now, where can we start? right? Where can we start here? Now, the best thing to start here, remember we are solving for x here, right? So, and this is an equation. So we want to get rid of everything that is next to the x so that we can isolate the x, right? Remember this was x to the power of what? This is same as 3 over 4, right? Is equals to 8. Now, what is 8? This is same as x to the power of 3 over 4. This is same as 2 to the power of what? This is same as 2 to the power of 3. Yes, this is what I wanted to do. And now from here, what is it then that I'm going to do? Now I can multiply by 4 over 3 and I multiply by 4 over 3, right? So now here the 3 and the 3 are going to cancel, the 4 are going to cancel, which means my x is going to be same as what? Now the 3 here and 3 are going to cancel, which means this is 2 to the power of 4. And then what is 2 to the power of 4? This is going to give me my 16. Are we fine, right? So basically that's going to be the first expression that I am going to have here, or equation that I'm going to have in here, right? So now let's look at the second one. Right, let's just make up our space and look at the second one and see in terms of what is it that we can do in the second one. Now, in the second one, can you see that here you are having what? Look, here you are having 5. This is 5 to the power of x. Right, this is 5 to the power of x plus 1. This is going to be plus. This is the same as 5 to the power of x is equals to 150. Altogether. Now, this is more of now an easier question for us to attempt, right? So because now from here, let's see, for example, we can start by writing these in factor form. This is same as 5 to the power of x multiplied by 5 to the power of 1 plus this is same as 5 to the power of x is equals to 150. Are we fine, right? And what is it then that we can do now from here? Now we can take out a common factor between the two, right? So can you see that 5 to the power of x is common, right? And when 5 to the power of x is common here, I'm left with 5 plus 1, which is going to be same as 150. Are we all fine, right? And then now what is it then that I can do now from here? This is going to be same as 5 to the power of x into bracket. This is 6. This is to the power of 150. And now what is it then I'm going to do now from here? Now I am going to start by dividing by 6 and divide by 6. Are you all fine, right? Now, which means now this is same as 5 to the power of x is equals to now, when I say 150, right? 150 divided by 6, this gives me my 25, right? Which means this is going to be 25. And as this is 25 now, I can express my 25 in terms of 5, right? So can you see that this is 5 to the power of x is equals to this is 5 squared, right? Now, which means now because the bases are the same, now I can say my x is going to be equals to 2. Are we fine, right? So which means whatever that I'm going to have here as my x is going to be given by 2. Are we all fine, right? So basically now that's what we are going to have in here. Now let's move swiftly along then and look at the last question that we are given, right? So here we are going to attempt the last question and see in terms of what is it then that we're supposed to do in the last question. Now, in the last question, right? I know they like these types of questions, right? Now, they say without the use of a calculator, right? They want us to show that 9 subtract root of 54 over 6 root 2 is the same thing with this 3 into root 2 subtract 2 into root 3 divide by 4, right? So here they want us to prove that left hand side is equals to the what is equals to right hand side. So I am going to use my left hand side to prove this, right? So what is this going to be now? Let's look at this. For an example, if you start here, what is 9? Can you see that 9? This is going to be 9 subtract. What is 54 for an example, right? So if I do my 54, right, my root of 54, it's actually same as 3 root 6, right? So this is actually same as 3 root of 6. This is going to be divided by what? This is divided by 6 root 2 altogether, right? Can you see that what is it that we did in here? Now, after here, what is the first thing that I'm going to do now from here? Now I am going to start here and say now, look, because I want to solve my numerator, right? And my denominator, I want to have a whole number. So I must start by multiplying by root 2 here and also multiply by root 2, right? So which means I'm going to multiply by numerator with the root 2 and also my denominator with root 2. Are we fine, right? And how can I do that, right? So which means now for an example here, which means this is going to be same as This is going to be same as root 2 into this is going to be 9 subtract 3 root 6 divided by what? Divided by this is going to be 6 root 2 multiplied by what? This is also multiplied by root 2, right? That's what I'm doing here, right? And then now what is going to happen here, which means now in my numerator, I am going to have what? This is going to be same as 9 root 2 subtract. Now, when I say 3, right, now from here, I want you to look at this carefully here, right? Now, if I am saying this, right, can you see now from here, this is actually same as 3, right? The 3 root 6 is same as what? This is same as 3 root 2 multiplied by root 3. Why am I saying that, right? Because now what is 6? 6 is same as 2 multiplied by 3, right? Remember here we had 3 root 6 altogether. And 6 is same as what? 6 is same as 2 multiplied by 3, which means now I can represent that in terms of that root. Are we all fine, right? So which means now before I can do that, right? Let me maybe start by actually writing it in that way, which means this is same as what? This is same as my root 2 into this is going to be 9 subtract this is same as 3 multiplied by root 2 multiplied by root 3. Oh, to get right? Now this is divided by what in here? Now can you see this is going to be same as what? Root and root is going to give us this, right? It's going to give us 2, which means this is same as 6 multiplied by 2. Are we fine, right? Now I can start distributing here. When I distribute here, this is same as 9 root 2. Subtract now. What is going to be this one in here? This is going to be same as 3, right? This is going to be same as 3. Remember, why am I saying that? Remember, this is same as root, and root is going to give me my what? My 2, if I'm not mistaken, right? So this is going to be same as 3 multiplied by 2, and then 3 multiplied by 2. Then this is going to be same as 3 multiplied by 2 root of what? This is 3 multiplied by 2 root of 3, if I'm not mistaken here. Okay, so basically, this is what I am going to have in here, right? This is now, yes. So basically, this is what I am going to have over here, right? Right? Let's see that I have multiplied this one correctly. Let me just fix this one correctly now. This is same as, right? This is same as 3. Remember here, when I was multiplying here, when I was multiplying by root 2, yes, this is correct. This is same as 3 multiplied by 2, then this is going to multiply by what? Multiply by root 3. Oh, it's again, right? Because now the root and the root here, remember this is one term, right? So I must treat this as one term, which means the root 2 and the root 2 multiplied each other. That's why I am having 2, because when I say root 2 multiplied by root 2, I am getting what? I am getting my 2, right? This is going to be divided by what? This is going to be divided by 12, right? And now after that, what is it then that I'm going to have here? So which means now I can start by saying, look, this is going to be same as what? This is same as 9 root 2 subtract 6 root 3, if I'm not mistaken, right? Divide by 12. Now I can take out a common factor here, right? And which common factor that I can take out over here? I can take out a common factor of 3, if I'm not mistaken, right? So if I take it out a common factor of 3, what is it that I'm going to have? So this is same as 3. Now I am going to remain with what? I am going to remain with, right? Let me write this. If I take out a common factor of 3, this is going to be same as 3. I'm going to remain with 3 into root 2. Subtract what is going to be this one. This is same as 2 into what? This is same as 2 into root 3. Are we fine? Then this is going to be same as over what? This is same as over 12. And then now I know that my 12, it is, or rather I know that my 3 is divisible both sides, right? So what is that I'm going to do? Which means now I'm going to say 3 here, how many times? 3 here it's once, and 3 here it's how many times? It's 4 times, right? So which means the solution that I'm going to have here, it's going to be same as 3 root 2. Now subtract 2 root 3 over what? Over 4, right? Which is indeed the same as what I am having in my right-hand side altogether. So basically, this is how we are going to go about whenever we are solving this particular question, right? So I am hoping that all of this makes sense. I know this particular video took very long, but this was for a good cause so that we can have a proper understanding on how we solve our exponents and also sets. Thank you very much for listening.